number 78. Title is Parallelogram. Parallelogram is a quadrilateral. So a quadrilateral just means that it has 4 sides. So a triangle has 3 sides. A quadrilateral has 4 sides. But a parallelogram is a special kind of quadrilateral. So it's not just any old 4-sided figure. It's a quadrilateral with both pair of opposite sides parallel. Parallelogram is a quadrilateral with both pair of opposite sides parallel. So here's one possible parallelogram. So this is a parallelogram. And the reason why is if I extended this side forever and also extended this side forever, they would never hit each other. So this side is parallel to that side. And also, if I extended this side forever and extended this side forever, that top side would never hit that bottom side. So that's parallel to that. So this side's parallel to that side, and this side's parallel to that side. So we have both pair of opposite sides parallel. So that makes this a parallelogram. Now don't get mixed up between length and parallel. It's possible. So those two lines are parallel to each other. They're not the same length, but they're still parallel. I've just noticed over the years, after a while, people start getting mixed up between how long they are and whether they're parallel or not. These are parallel, even though they're not the same length. This is parallel to this, and this is parallel to this, so that makes it a parallelogram. So that's the definition of a parallelogram. But then there's other things that are true. So here's Theorem 1 about parallelograms. Something else that's true about parallelograms automatically. So it turns out that opposite sides of a parallelogram are congruent. Opposite sides of a parallelogram are congruent. So that's why people get parallel mixed up with length. Because it turns out that this length is the same as this length on a parallelogram. So if you measured this and it came out to 4 inches, you wouldn't need to measure this side because it would also be 4 inches. And also up here, if you measured this and it came out to 7 inches, you wouldn't need to measure that because it also comes out to 7 inches. So it turns out that if you have a parallelogram, if you know that for sure, then the opposite sides are going to be congruent to each other. That doesn't mean we're saying that parallel means congruent. It just means that if it's parallel, then it's going to turn out to be congruent on a parallelogram. I mean, that's not always true. Here it's parallel, but it's not congruent. But if you have a parallelogram, it's going to turn out that way. Okay, then also, so this is Theorem 2, opposite angles are congruent. So remember, angles have to do with rotation. So how much you're rotating. So if you start here and rotate down to there, that gives you an angle. And so let's say we pulled out our protractor and measured that, and it was 110 degrees. Then you wouldn't need to measure this one. It would also be 110 because opposite angles on a parallelogram are congruent. Okay. Then the next thing that's true about parallelograms is consecutive angles are supplementary. Consecutive angles are supplementary. What does the word supplementary mean? Yeah.
Adds up to 80 degrees?
Yeah, good. Adds up to 180. So that means angles that are consecutive are going to add up to 180. So if you measured this angle and it was 100, and you knew this was a parallelogram, which we know, then this would be 80 because these angles are consecutive and they are supplementary. Now, actually, we already knew that that was going to happen from a theorem that we had before, because if you have two parallel lines and a transversal, then these are called consecutive interior angles, and they're going to be supplementary. So this fact just comes from the old fact that consecutive interior angles on parallel lines are going to be 180. So that's why these consecutive angles are 180. Okay, then the last thing that we're going to mention about parallelograms is the diagonals So this is the first time we've had the word diagonal, so I have to explain what a diagonal is. So a diagonal is a line that connects 2 points on the figure. So here's a point on the figure, here's another point on the figure. So that line that connects those is called a diagonal. And then here's another point and another point, so there's another diagonal. So there's the two diagonals on the parallelogram. So here's what happens with the diagonals. The diagonals bisect each other. And the word bisect means cut each other in half. So that means that here's the first diagonal, and it's getting cut in half. So that means this piece is equal to that piece. So if you measured that piece and it was 2 inches, you would automatically know that that was 2 inches also. And then here's the other diagonal. And according to what that says, it's also getting cut in half. So this is cutting that in half. So that means this piece is equal to that piece. Now you can tell that this piece is shorter than that piece. I'm not saying that they're equal to each other. I'm just saying that that is equal to that, and that is equal to that on a parallelogram. Diagonals bisect each other. All right, that's it for the note card. Here's the hole punch for you. And the paper is called Geometry 6-1. So there's a picture of a parallelogram on this paper. So they tell you this is a parallelogram. And then in number 1, they give you some more information. They said that the measure of angle BDC is 125. So B to D to C, that's that angle there. BDC is 125. And the question is asking what is the measure of angle BAC. So they're asking B to A to C, which is this angle there. So what is the measure of that? Yeah, Taylor? 125 also, good. And then the directions also say give a reason for your answer. So how do we know that this angle is 125? Yeah, Manny? Yeah, on a parallelogram, opposite angles are congruent. So since this one was 125, that one's 125 also. Opposite angles are congruent on a parallelogram. So number 2 says BD is equal to 10. When they write B right next to D, what does that mean? Distance or length. Good, Jennifer. So this means the length from B to D is 10. Maybe it's 10 centimeters. They didn't label it. So they measured from there to there, and they got 10. All right, then the question is asking what is the length from A to C equal to? Yes, Charlie? Good. So AC is 10. And how do we know that? On a parallelogram, opposite sides are congruent. Okay, number 3 says the measure of angle ABD is 80. So this time they measured up here, ABD, this rotation. Okay, thank you. Here's a note card for you. Sure. So ABD is 80. And they want to know what the measure of angle BDC is. Yes, ma'am. Awesome. So this angle was 80, which means this angle down here is 100. And how do we know that? Yeah, Manny? Theorem 3, which says consecutive angles on a parallelogram are supplementary. You can skip number 4, you don't have to do it. The reason I'm saying that is I accidentally didn't even number a problem number 4, so. So number 5 is talking about A to E, which isn't even in the picture over here. So there's more to the picture. They drew the diagonals in. And this point here is E. And they measured from A to E, and that came out to 3. 3 inches or whatever they're measuring it. And then the question says, find the length of DE. So they want to know how far it is from there to there. Yes, Maddie? It's also 3. And that's because on a parallelogram, the diagonals bisect each other. So if one piece of the diagonal is 3, the other piece has to be 3 also. Then for number 6, it says the measure of angle BAD is 40. So BAD is that angle there, and they're saying it's 40. And then they want to know the measure of angle ADC. So first of all, if you see this angle walking down the street, stay away from it. It's my first joke. I know you missed my jokes. Over spring break, you were thinking, I really want to go back and hear some good jokes. So there's one. Okay, so anyway, this problem is a little tricky because the theorems we talked about over there didn't say anything about this angle. They didn't say anything about the diagonals and the angles formed by the diagonals. So I'm going to redraw part of this picture. So here's BA, and then here's DC. And what do we know about BA and DC? They're parallel to each other, right? Because it's a parallelogram. Okay, so now I'm going to draw this line in. That's called a transversal. So if you just look at those 3 lines, we have 2 parallel lines and a transversal. So then what are those angles called? This is a little tricky because it's not today's stuff. Yeah. They're alternate interior. Good. So those are alternate interior angles. And they told us this one was 40. So then what's this one? Sorry, they told us, yeah, they told us that one was 40, so that one's 40 also. And the reason why is when you have parallel lines, alternate interior angles are congruent. When lines are parallel, alternate interior angles are congruent. So when you have a parallelogram, there's parallel lines, which then you know other stuff about angles formed by parallel lines. So that's what's going on with number 6. So when you get the paper, you can start with number 7.